Right, welcome back, Physics 30. Today what we're going to do is, instead of going through the ray diagram again, where if you guys recall from yesterday's lesson or last lesson, you may notice that ray diagram is commonly used to create an image, a predicted image, after an object go through the light and being either reflected or refracted, one way or another. Now, today you may notice that drawing the diagram every single time can be tedious. And even if you draw, if you look at the guideline, like smaller, larger, inverted, you may want to know, like if it's smaller and larger, how much, basically, is your question. So today's lesson involves equation. In your Physics 30 booklet, page 22. And if you go to data booklet or formula sheet, you will have these two formulas. Basically, one of the formula talk about the relationship between distance of an object, distance of an image, which explain this O and I as a subscript, and F for the frequency. Sorry for that little technical problem. Now let's go back to our topic. Yes, the first formula involved DO and DI. O represent original object and I represent image. So it's either reflected image or refracted image. F represent the focal point, like our focusing point. You can think it in that way. D, as you may notice, represent the distance, horizontal distance along the PA. So I like to point those two out over here. Principal axis along PA. Now, H represent height. Same thing E for an image. So height of an image. O represent original object height. Like it can be candle, yourself, those kind of thing. DIDO, you may notice HIHO, DIDO, it's a ratio differences. This negative sign is what I want you to focus, by the way. Because depends on what type of image you're dealing with, you're going to use negative and positive, which we're going to see it. It's in fact depends on the real image versus virtual image. MAG, basically it's a short-term words of magnification. So, if an image is large, this will be a whole number or bigger number, like 3 point something even. On the other hand, if this magnification is 0.5, that means your image is half of its original size. So it is fraction or decimal representation. And like I mentioned over here, object height is basically whatever the exact image of candle or yourself, that's a height of HO. HI is image, so it can be inverted. Now, sign plays such a huge role because sign is one of the way that we can, size is one of the way that we can use as a positive and negative, and sign is negative for virtual, positive for real, something like that. So we're going to talk about that. And when it comes to R, this is radius of curvature. So from previous lesson, this was represented by the distance C, which is double the distance of F. Now, sign convention. This is really significant. Now, in diploma, it plays a huge role too. D, you have to use positive for the image if it's real image, which means intersection between the solid lines versus virtual. If you guys remember, the dotted line that intersect, those are positive and negative. F represent, so basically if it's positive F, it's converging. Things are concentrated. If it's convex lens, like the one that you see over here, it goes towards the right side. So think about this is 0, positive and negative, something like that. On the other hand, if it's diverging, it's dotted line and go back, so it is located on the left side. So converging, I want you to always understand as positive. and I'm gonna say positive side of principal axis. Diverging is negative, and I'm gonna put negative side of principal axis. Something like that. And h, of course, is height, but if hi is negative, it's inverted. You can think of negative y value, like what you see over here. It's going below 0. And if it's up, it's like positive y. It's going upright, erected image, whatever you want to call. It's the same thing. Except these h is perpendicular to principal axis. Like I mentioned, if the magnitude is bigger than 1, that means, smaller than 1, so 0 point something, blah, 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 then it's smaller image. If the magnitude is as long as it's bigger than 1, in terms of quantity, it's a larger object. So once we know these value and then use a calculation, we don't technically need to draw ray diagram like what we did before. Without further ado, let's do some example. Today's lesson is quite straightforward. Now, let's go with this example number 1. 20 centimeter tall object is placed in front of concave mirror with a focal length of 80 centimeter. If the virtual image is 133 centimeter from the mirror, then determine the height of an image. Interpret all the sign. So let's talk about what's given first. Height of an object, which is always positive, 20.0 centimeter. Focal length. Now know the fact that we need to decide the sign, but it's 80.0 centimeter. Now, how can we know if things are positive or negative? Let's talk about concave mirror first. Concave mirror goes like this. And if you think about it, imagine you're drawing image in your head. You may notice that this is a situation where object will go towards the center, which means it is converging. If you want to double check, let's go back to our page over here. Now, we need to determine whether it's converging or not. Concave mirror are concentrating towards one of the side using a real line, so it is positive F. Because, like what I mentioned before, any type of converging mirror or lens, they have to be basically positive for any of a focal length value. So, put that. Now, virtual negative. You may notice that we have image is 133 centimeter from the mirror, but because it's a virtual, that means it's opposite side than where the image is showing up. So that's why we need to have negative sign for that situation, 133 centimeter from the mirror. Determine the height of an image is basically what we have. Now, to apply this, we need to know DO, where is an object is actually is. So, first step is finding out the DO, and second step is finding out HI. To find out DO, you need to use first formula, which is what you see over here. 1 over DO plus 1 over DI is equal to 1 over df, and we are isolating for this guy. So subtract this on both sides, or move this to the other side by subtracting. Same thing. 1 over do is equal to 1 over f minus 1 over di. Now know the fact that it's reciprocal of everything. Then flip the whole thing. do is equal to 1 over, bracket open, 1 over f minus 1 over di. Now, once you have this situation going on, what you need to do simply now is basically punching those numbers in. do is equal to 1 over 80.0 minus 1 over minus 133. Know the fact that I'm putting multiple bracket in here. Now, let's punch those numbers in. First thing first, 1 over 800, that's what I have, minus 1 divided by negative 133. I'm doing denominator first, and that answer, I just need to do 1 divided by that number. So whole DO is in fact 114.0407 ... centimeter. It should be the same unit. Now, know the fact that I am not going to use rounded answer because in the end, I need to find out my height of an image, which means I need to use my magnitude formula over here, HI over HO, DI over DO. With negative sign. We can simply bring this to the other side by multiplying. So, long story short, HI is equal to negative DI times HO over DO. And I'm going to put this value with the negative, don't forget, and HO, which is 20.0 centimeter, divided by DO, which is, that doesn't belong as an image. Sorry, folks. That belong as a denominator, which is easy to fix. DI is negative of negative 133, so you can just change into positive 133. And now we're going to punch those number. 133 times by 20.0 divided with my previous answer, which is DO, give me height of an image is 23.325 centimeter. So HI, in the end, I can round it up to significant digit. I have 3 significant digits in this entire system, so 23.3 centimeter high. Now, know the fact that it gave me a positive answer, so I can just say that H is upright image. If we need to talk about every single property, like last drawing lesson, it's virtual, upright, and HI is 23 versus 20, so it is slightly larger image. That's how we can use algebra and formula to find out the reflected image or refracted image. Now let's do the other part. An object is located at 15 centimeter in front of convex mirror. Now convex mirror, if you guys remember, it looked like, my drawing is horrible, but you got the idea. It reflects things off because it's bended this way. It's a belly situation. You're reflecting everything off, and then you may notice that they're going away from each other. So it is diverging situation, just for the heads up, which give F value as negative in that situation. If the radius of curvature is 10 centimeter, so C is 10.0 centimeter, or some people put R, radius of curvature, doesn't really matter. Find out the magnification. MAG is equal to question mark. And interpret all of the sign. First of all, we have DO is given, which is 15 centimeter. And whatever object size, height, and distance is always positive. Now remember, if I divide C by 2, then you have focal length. Radius of curvature is always double the distance of focal length. So it is 5.00 centimeter. Don't forget your negative sign. Negative 5 is what you need to put. And DO is positive 15. So we have everything is given. Now, how can I use the whole clue? First thing first, in this situation, we need to find DI first. Why? It's because in order to use magnification formula, we can use the last half. DI over DO is equal to magnification. So let's use, and this is my planning step, let's use my formula. 1 over DO plus 1 over DI is equal to 1 over F. I'm isolating for this one. So I gotta move everything to the other side by doing subtraction. So 1 over di is equal to 1 over f minus 1 over do. Now, flip the whole thing by doing reciprocal. Therefore, di is equal to 1 over f minus 1 over do. There you go. We have our modified formula over this situation. Now, punch those numbers in. And don't forget your negative and positive sign. Negative 1 over 5 minus 1 over 15 will give me my di. And now, calculator time. Let's do 1 over negative 5 first, which is negative 0.2, minus 1 over 15, which is my denominator, and reciprocal of that answer, negative 3.75 centimeter is my image. And note the fact that this is negative, so although the question does not technically ask you, but it gives me virtual image, which you can support or interpret all the sign situation. Negative di means I have a virtual image. Now, magnification. We are using the last half of magnification formula over here. Don't forget my sign, and I need to isolate for do, so which is just flip and switch situation. do is equal to negative di over magnification. And I thought we were trying to find do, but in fact, it's even easier. You just need to find out magnification, and we know both of the number. Then it's a simple punch the number in. Negative of negative 3.75 centimeter over do, which is 15.0 centimeter. You may notice that centimeter cancels each other. Negative and negative turning into positive. So my magnification is positive, and I can easily say 3.75 divided by 15 gave me 0.25. 0.25. Now, what does that tells you? First of all, let's think about positive over here. If I look at first half of the magnification formula, hi over ho is positive. You know that height of an object is always positive, which means the only way that I can have magnitude as positive is my image itself is positive, which means this is an upright image. I can have that conclusion. And in fact, the value is smaller than 1. In fact, it's 0.25, which is equivalent of 1 over 4. It is definitely smaller image. You can conclude that it is 1/4 of an actual height of an object through this convex mirror. That is today's lesson, ladies and gentlemen. Your job is, we did page 24 last time. Now you can do every single question on this page 25 of my booklet and page 26 all the way to 27. Every question you can use formula at this point. It is definitely more question than before, but lesson is definitely less than that. So I want you to work on it. Thank you.